Good afternoon. My name is Veerachai Tanpipat. I'm from the Hydro and Agro Informatics Institute. Belong to Ministry of Science. We doing water management in Thailand. We try to provide technology, and you see how. Uh, so I'll just introduce it to HAII. The Japanese call it HAI. Um, the Danish call it HAI. I just call it HAII. So it just depends. Our mission and activities. We have a lot of activities and a bit of conclusion. Okay. So it started long time ago with the King Rama IX initiative, and it was enacted. By that time, Dr. Royon was there. And so later it's developed it, and we have the telemetry system installed all over the country. Then in 2009, it's officially in the royal decree. So we are official funded by the government. Uh, so you see that our mission is just to try to get the science and technology knowledge to the people, to to help them for the agriculture and water resources management to make it like more efficient, make it more resilient, something like that. Like I heard about disaster a lot. Like tsunami, I was there. I'm nearby. I was diving, but but then I'm from Phuket. So I lost some relatives from that tsunami. But after that, we have a lot of development. But before, nobody knows about it. Not many people, but the sea gypsy, none of them die. They live by the coast. They said in the village, they have the story that telling generations that if something like this happen, just move up to the mountain or to the higher ground, you will be safe. Or like 24 hours tsunami hit in Phuket. I just go there. I'm one of the rescue team. So I saw many dogs. None of them died. And I asked, and they said a few, like maybe 1 hour before tsunami hit at Khao Lak, all the dogs move uphill. Yeah, because when you have a lot of bodies, when I just arrived at night, and then so many bodies on the ground, but the dogs there in front of the house, it's just nothing. I mean, like for them, but when you ask later, the story is that they move uphill an hour before. Buffalo died because somebody tied the guy up. They cannot go anywhere. That's maybe the system that I just joking that maybe you just follow the dog to save your life. And yeah, just out of the context a bit. Then our mission is just doing the research uh, and doing the development, expanding service, and make collaboration. So we have three areas that we work on the real-time monitoring, the forecast system. We have our own telemetry system, and we have the system integration. So we do also the big data, the warp ROM, weather prediction, and we have the flood decision-making system, and we do the climate change adaptation because lately it seemed to be like it's happened, but somebody said it's not. So I think it's happened. And this is the system we have at the currently expanding. But the problem, like we have 850 on our own online, and every 10 minutes update, and it's open to the public. And I talked with a colleague in Indonesia. Also, the problem is that we concern is that the quality of this data, because different, you pay higher. We build our own, but compared to the very high high price sensors, they get more accurate data. So we have to concern about that too. And this station, some of them have the water level, the radar to measure the water level. And this is the survey system we have. We have almost everything, but cannot cover the whole country. This one, for example, is just a robot. The board just to make the map of some area that you need.
Does the ball measure the depth of the water?
Right. You make a map, underwater map, to see. Actually, you do this to the canal before the water coming down from the north from Thailand. It has to go to Bangkok. So you use this a boat to measure where is the depth. If it's not that deep, you have to ask somebody to dig something out. So
Coastal area, to this one to the coastline.
yeah. It's controlled by the map. You know, like UAV, like not your like EB system. You can make the map and then it's gonna follow that. This is from the product from one of our colleagues in another department, but under the same ministry. No, not ADC. ADCP is just a organization that using data. They don't do this. They ask us to join, and they try to use our data, but I don't know the exchange of the sharing data is a problem. You just take, you have to give to, but you just cannot come from USAID project like SWIA project. Come here and then you have a workshop, have a meeting, and then give us data. Not that simple. Very difficult. That's why I'm asking because I'm seeing this sharing data for over 20 years. It's not working. You have to give both sides, not just taking. So it's quite difficult. That's, that's why I asked the question before. And this is just our system and expanding. We also have the mobile one, but in case of emergency, we have the trailer to go out to communicate and then have a mobile center, command center. These all after 2011 flood. You get all the money. And this is what we do with the integrated model. We do the warp ROM. So this one, the best accurate is 3 days prediction, maybe 80%. But go to 7 days, it's different story. It's like you can look at the trend, but accuracy is low. So for the like seasonal, not seasonal, a month forecast, very difficult to make it accurate. Yeah. We try to improve this, but not quite difficult. I mean, it's difficult. So 3 days, okay. More than 3 days, just a trend. And we also do the wave. Okay, and go quickly. It's a bit long, and we do this. I'll show you later what we have. We are doing working the close project with JAXA, GS Map to improve their product. So this is one of our colleagues, Dr. Vinay, doing this, the gamma transformation bias correction to improve the GS Map product and put into water model. This is like you have all the information you put in the water model, and then you know how to manage the water in the country. And we also have this flood forecasting system. This based on the DHI, the Danish Hydrological Institute. So you have like My11, you have MyUrban to run, but with different parameters and the input data give different results. So it depends. After the flood 2011, JAXA came with the LiDAR, 1 meter resolution to fly over this Chao Phraya River. This is the central one, and give us the data. But later when we check, the accuracy is not that good. So now we're trying to get a project to get better LiDAR to fly again, but not funded yet. And later, after 2011, now we have the so-called the National Hydroinformatics and Climate Data Center, over 34 agencies sharing data. But still, it's not that easy to work. When the time comes for the disaster, that agency give, that the other agency doesn't give. This director go to the prime minister, I know more, something like that. To get more funding, it's still the problem, even that, This is within the country. But we have the system, this system is at the HAII, But yeah, still, and everything, we have this decision support system. All the information we have, put in this, and we have to give the whatever that scenario to the decision maker to make it, and it depends again on the decision maker. If you have the one that doesn't know about it, just happen to be in the position, the decision came out wrong again. That's also the problem. You know, in Thailand, I don't know elsewhere. Same. See, like I said, you spend a lot of money with the information technology you develop, and then you give it to the guy that he doesn't know anything.
Yeah.
So it's going to be difficult. And this online decision support system with the watershed, different watershed in Thailand. So you can see it. The one that operate already is like three of them. The one at in the central Chao Phraya River, that one, and then the Khong Chi Moon River. I mean, basin. This Khong Chi Moon is like from China and go out in Vietnam. So it go through many countries. And this is with the normal operation daily. We have this like kind of war room center, watching over, monitoring everything, all the data coming in. And with this crisis situation, like I said, we have this trailer with all the equipment, I mean, for the computers analysis thing going out because of the communication system. It's happened in tsunami. All system lost. So one of my professor, maybe you know her, Dr. Kanchana from AIT. She asked me to put some sensor or communication on the elephant and communicate, because after tsunami hit, you lost everything. You put this communication system on the elephant. Before she would let you use the dog. I said, oh, difficult. Then he changed to elephant. Then the elephant can walk and take a video and communicate and send this data back to Bangkok. They use the satellite dish to set it up and then to make emergency communication. And later they use the boat. They put on the boat and go outside after tsunami and then delay the signal.
In the future, it'll be mobile.
Yeah. And this is also the same that this is online that you can look at the website. The data itself, raw data, is you have to get a letter to get the data, because before we open to everybody, and some private company using this data wrong way, and we got blamed for that. So now we need proof of a letter, at least like, okay, you get it, you use it in something. Okay, we didn't do it. Also, this is like the CCTV is online, and the telemetry information, the water flow, you can access. This one you can. You can look the water coming down from the north, going out to Gulf of Thailand. You can monitor all the way. So, but not all of the CCTV work. When you try to look at the critical area, it tend to be not working. Don't know why. But they say sometime because of now they changed it to solar cell or something because of the power. Before, in 2011, it got flooded and then the electric gone. Then we also try to do the drought monitoring system also, because we also responsible for the agricultural. And this is what I'm talking about, the GS map. It started 2 years now with the JAXA team, the GS map. We have a purpose to get they call it the near real-time product from them, because we're trying to predict the flood. But the problem is that the data from GS map itself is not correct. You have to do the bias correction with the gauge, everything. So now we are doing it. The JAXA team who wrote the code, fixing it, changing 2 times already now. So we still have to test it. So the last incident happened in Thailand is in last January that JAXA monitors closely. That is the guy, Kubota-san, that you can contact him if you would like to know more about the algorithm. And this is what happened with the anomaly that in southern Thailand. This the satellite capture it. It's called it now be very concentrated in the extreme event. It's very difficult to predict and difficult to follow. And from this event, we then try to do the bias correction for the local. It's difficult for the southern. They pick the southern part of Thailand because it happened. The flooding, the landslide happened too often lately. And the difficulty is that because of the strip down from north to south, so you have the ocean effect from both sides. So it's like, and then mountain ridge. Okay, and then during that incident, nobody mentioned this. This is very important. Free for every country is provided by the international charter from all the space agency or the satellite company. But you have to apply for it. Thailand, not yet. I'm trying to, but they don't want to be responsible for. Just one phone call to UN. That what I did last January to my friend in Geneva, and then 3 hours ESA flew over the Sentinel-1 and took photo, and then they send the data to APAC or whatever to Colorado University to Bob Brisket, and we get the flood map. Yeah. They're doing the global daily flood monitoring anyway, but they need more data. Like when you get the flood when the time of flooding, it's cloud coverage, so the optical cannot do good job. The microwave is better, can penetrate the cloud. And we also doing this with the JAXA for land use cover change using the Pulsar 2 and Sentinel-1 to improve. This finally we'll put in the water balance. And we use the APAN network testing this, just the result. And we download it every day and run the warp raw model through using APAN. If the shutdown of APAN is going to be problem, because we cannot run our model. And then this is the scientific that we're trying to put into the community. This is the end result that you go down to community. Just going quickly because of the time. You can read later. And the community started in 2003, only 2. Now we have 603. No, more than that, 872. But this is funded by Coca-Cola, the company. So you have the money all the time, not from the government. And all the information we put through this, we call media box as well. Okay. And the application, this is most of the people using this, using the web application, I mean the mobile application, so easy for them to access simple data. It's good example, you can look at it later. Many to improve. I intentionally put this in because it's good example to improve. And conclusion, as we started, this is our belated king. He said before that you have to go back and start it with people at the community level to build the resilience. You cannot prevent disaster. You cannot deny it. It's very difficult. It's hard. But if people have enough strength, resilience, they will come back. You know, they will survive. So that's our motto at the beginning. So at the end, we're trying to do this, develop, researching, integrating, and implementing science technology for the better and stronger Thai society in a sustainable way, follow King Rama IX idea or initiative. Thank you.